So the problem here says that a spring with a spring constant of 18 Newton per meter. So if we level spring constant by K, K will be 18 Newton per meter. It has a cage attached to its free end. So the question is, how much work does the spring force do on the cage when the spring is stretched from its relaxed length by 7.6 millimeter? So basically, if we draw arbitrarily, the string, when there is this cage here and there is this spring hung from a firm wall or something, so the cage is attached, and this is, let's say, this is the relaxed position, but then the spring the spring is stretched from its relaxed position for 7.6 millimeter. So the movement from relaxed position to up to where it is stretched is 7.6 millimeter. So the question is, how much work is done by the spring on the cage? So in this case, the work will be actually negative, because the spring is sort of getting potential energy by this stretch, because now if the spring is released, it will do work on the cage. So work will be, W will be, let's say, negative here, 1/2 k x square, and x will be the displacement, the movement of the how much it is stretched, and that is 7.6 millimeter. We have to be careful about the units here. So work will be in joules, so we have to take everything in meter. K is given in 18 Newton per meter, I guess. Yeah, that's Newton per meter. Actually this should be Newton per centimeter, so I will correct that here. In the question it should be 18 Newton per centimeter, so I will write that. So here what's happening, half K, we have to convert it into meters, so 18 Newton per centimeter, so 18 here, and then if we convert it into meter, it will be 18 times 10, because 10 centimeter makes 1 meter, and then this is 7.6 millimeter, so we will do 7.6 divided by 1000 and then square, so that will be work done. Correction here, it would be 18 into 100, because that was Newton per centimeter. We need to convert it into meters, so that will be multiplied by 100, so it's 100 here, and this one, if we do the calculation, it becomes minus 5.2 into 10 to the power minus 2 joules. So that's the first part. In the second part, it says that if the spring is stretched an additional 7.6 millimeter, how much how much will be the work, how much additional work needs to be done. So when we do that, since the relationship is not linear, we have to start from the beginning, from the relaxed position. So what we should do, we should use the same equation, minus half. This time also the work done by the spring on the cage will be negative, because it's still pulled down. So minus half, again 18 times 100, that's Newton per meter, and then this will be 7.6 times 2 plus 7.6, let's say 2 7.6 divided by 1000 and then square. So now it becomes, so once this is done, it's negative, this is becoming approximately 0.21 joules. So the additional work that needs to be done will be this one minus this one, because this one was to stretch 7.6 millimeter, then additional 7.6 millimeter is stretched. What is the additional work done? That will be this one minus that one. So I don't know, maybe additional is minus 0.21 minus here 5.2 into 5.2 into 10 to the power minus 2, so that's approximately 0.16 probably joules, approximately like that. So basically what's happening here is this one we calculated to stretch the spring for 7.6 millimeter. Then another 7.6 millimeter was stretched, but when we wanted to do the additional work, we cannot start from, what we did is we started from initial position and we calculated the work done for stretching the whole 7.6 plus 7.6 millimeter, the total one. And then from that total work done, we have subtracted the initial the work done due to the initial stretch. That way we found the work done for the additional stretch, and in all these cases the work done by the spring on the cage will be negative, because the spring is still with this work done, it is done actually on the spring, so done by the spring will be negative. And in this process the spring is attaining its potential energy sort of, so once it's released it will do work on the cage. So